Can I start now? Should we wait? I should start now? So there's no opening lah, since we just few people only. So I'm just gonna be talking about like Rust closure and how it works. I mean internally how it works. So as usual, what is a closure? So it's a function that can directly use a variable from the scope in which it is defined. So usually in most programming language, closure is associated with like lambda as in Python, or like anonymous function. But those two are not really exactly the same. So closure is like an environment that basically captures all the variable from the scope which is defined basically. So this is an example from Russ. Can I zoom? Wait, hold on. Okay, cool. Okay, so some terms. So here we have, I mean, this is how we define closure in Rust. So we have like a my closure, and then we have like a double pipe. Double pipe here because there's no input basically, and then we call a function like do something, and we pass a reference of text here, and then since this variable is not since this variable basically the scope of the variable is from the outside of the closure, so we call this text variable a captured variable. So and then we just like call my closure here just to run the anonymous function. So here we have a closure that is written with a language with GC, a garbage collected language basically. So we have a function main that basically create a function that add 1 to a given number. So we give it a 5, and then it returns a function that basically add 1 to the number that we pass in, and then we get back the result here, and then we print it. So this works fine in any language with GC. But what if we were to rewrite this in Rust? So we have this function written in Rust, and it seems at first it's like there's no really a problem. So if we try to compile it, then we have, then it says, I mean like it cannot compile, then it gives you like a cryptic error if you're not familiar with Rust, that closure may outlive the current function, it borrows 1. What does it mean? So the function was the outside function was yeah, that's correct. So but the solution is pretty simple, but we do want to understand why this actually doesn't really work in Rust, because Rust has no GC. So in order to understand that, we have to go back on how the variable basically works in terms of the memory management.
It's only during Rust presentations where I can see stacks and keep moving the Very good.
And C like
It's like, it's like
So
no, but you went to the C this one, so you actually understand what is the difference between stack and heap.
yes.
It's just that those coming from a Ruby, Python, or
Yeah.
those,
That's why
they don't really get it.
one from the self-learners programmer, they need to go through CS50 is one recommended things lah. One of them is
You also started from C. This is like natural.
Yeah, so
Yeah.
I set up myself in C before I
We'll,
had a CS.
we'll allocate some time for you to speak about CS50 in front of camera afterwards.
I give review lah.
Don't be nice.
okay, I think so here we have a function that we have two functions basically, the main function and the add one function, but this is just normal function, ordinary function, nothing unusual. So I just want to show how the memory allocation works. So once we run the program, we go into main and then we initialize like a state frame, or in CS people usually call it like activation record or something like that. Yeah. No.
Not my terminology.
Okay. So we run the first line, which is 5, and then we allocate 5, basically like an object representation. For example, Python basically represent 5 as an object in the heap, and then in the stack frame we have a pointer 5 that basically point to the heap. And then we go to the next line, and then we run the add one function, which basically do the same thing, allocate 1 to the heap, and then a pointer from 1 to the heap. And then when we return from the function, we get like result. And since the stack frame is no longer needed, because there's no other variables that reference to the anything that from the stack frame, this one gets popped off from the stack, and then we print the result. Now let's see we have a function that basically create a closure that do the same thing, but instead of doing it directly, we return a function. So it's written an anonymous function, which is also a closure because it references 1 here inside the return anonymous function. So we run it again, we get 5. We have 5 like usual. And then we are back in the add one stack frame again, initialize 1. And then what happens is that when we return back from the add one function, this calculate basically holds a struct or some sort of representation of a closure. I give it like a fn here.
So it's not actually a function.
Yeah, it's not really a function, it's just like a representation. This is just at a high level how a language with GC works. So here the closure basically has a reference to 1 because we have 1 here that still need to be referenced. Here what happens is that this depends on the programming language itself. So for example, like Python do like a reference count. So like 1, so the garbage collector will watch the heap basically, and then it will collect all the reference count that hit 0 basically. But 1 reference count is not 0 because calculate basically still pointing to 1. So basically there's still a reference that using 1. And for example, like language like JavaScript, instead of like deleting the stack frame, this stack frame basically get unlinked. It gets unlinked, but it doesn't get deleted from the memory. It resides somewhere in the memory. So when we need to run the calculate closure, it still can refer to this stack frame. That what happens. So now the problem with Russ is that Russ doesn't have a GC. So there is no way for us to actually know that 1 is still needed. So if we were to like delete the stack frame here, and we probably would also be deleting the heap, and then the closure is pointing to the garbage memory now here because 1 is no longer there. So how do Russ actually solve this? So Russ has the concept of borrow checkers, or the ownership system of the Russ. So what Russ does by default is that when you create a closure, whatever captured variables, they are borrowed into the closure itself, the closures environment. So for example, we have the same example as before on the stack frame and the heap. And okay, I have a star here, so that depends on where you initialize the data, because in Rust we explicitly tells the compiler that we either allocate something on the stack or we allocate it on the heap. And then generally for primitive types like
how you do that? Normally, how do you indicate which is heap and which is stack?
So first we have the depends on the trait. So let's say for example, not really a trait, I mean like a primitive type basically, that yeah, the ins, the bool, and everything that can be I mean like all the really small types yeah. So and then let's say if you wanna allocate something into the heap, we can actually do like box it using like box, or we can create like a pointer to the object. We can use a lot of things like RC, things like mostly people use like box to basically like put into the heap, and then we get a pointer to the heap from the stack. So for example, here we have by default is borrow, and then this of course doesn't work because when this one goes out of scope, when this closure basically borrows a reference to 1, and then the compiler is smart enough to know that 1 lifetimes is or the scope of the ones is basically shorter than the scope of the closure itself. That's why you get this error saying that the closure may outlive the current function, but it borrows 1. So that's how it represented, because this closure basically borrows 1, and then it was saying that closure may outlive the current function because 1 doesn't live long enough compared to the 1.
That's just a warning that you can still compile?
No, you can compile. Okay. This is compile error basically. So because we cannot borrow, then we can actually move the variable, basically the ownership of the variable. So once we do that, so 1 here basically you can call it like live inside is being owned by the closure itself, because we move the ownership of the variable into the closure itself. So this one compile. So how we do this in Rust? So what's a nice thing about Rust is that sometimes the help here is like really helpful. So here it says like to force the closure to take ownership of 1, use the move keyword. So we say move, that means that it moved the ownership of 1 to here, to the closure. Now we compile, done. So everything is done. I mean it's so compile is happy, then we are pretty much done. Now how do closures implementation, how it really works, how closures are implemented in Rust basically. So we go back here to the code, the same code, and then closure basically is represented as anonymous and unique struct in Rust. So basically what is being done, or what's being desugared, is as you have like a struct anonymous closure. I mean the struct doesn't really have a name. I mean the name is internal to the compiler. This is just how we understand it. And then we have like 1, which is of type reference, because by default the closure borrows the whatever the capture variable. So the capture variable here has 1 and has type of reference to the in, right? And then what happens is we create a struct called 1 and we have a reference to 1 here. Okay.
Wait, I got a question.
Mm-hmm.
So normally, if you don't have the, let's just say the lines number 4 to the bottom, if they don't actually exist, that means that if you do not use closure at one point, okay, if you say let 1 equals to 1, when equals 1, that means is that 1 is allocated on the stack, isn't it?
Yes, correct.
Okay. So only because of you move 1 to the closure, then become 1 is actually heap located.
Oh no, it's still in the stack. It's primitive stack.
Okay.
Yeah, because actually this example should use string. So because string can be allocated in the heap, but I just want to make it simple. So you can just like imagine it's being allocated in the heap instead.
So how and where does the stack actually clean up after you return the closure?
We will see. We will see after this, I think. Yeah. So
moving things, moving the ownership to something that lives longer than this one. I would imagine that at least the low level C is that when you return from a function, the stack the stack frame for that particular function gets cleaned up.
yeah, it's always being unwind. It's always like.
Yeah. So the implementation of the. Okay. I will see how it goes.
So the struct here, and so we are not done yet actually, because this struct basically implement the closures trait. So there are 3 traits to this. So we have fn ones, which, and then we have fn mute, and then we have fn. So the Rust compiler will implement at least one of these. So all closure basically must implement fn once, and depending on the situation, it will also implement a trait fn mute and fn. So depending on the situation, I will explain the situations. So basically what happens is that we have like implement fn once for an unclosure, and then we have call once self. So what happens at self is refers to 1, which is here. So basically it's like x plus self1. So x being from here. So if you notice this line is actually the same one as this one. So when we call the closure, the closure is being called here. Then it's actually call once. So I have like a typo there.
Does it mean call once mean that it can only run once?
Yes, correct. So that's why I say it depends on the situation. So basically, the Rust compiler will see how the body of the closures.
That makes sense because there's a lot of migration in low level.
So it also implement fn mute, which takes basically done the same thing as once. This is called like call mute, and then this is just call. So the diagram here shows that we have like all these circles, right? So this circle is basically the constraint. So if you were to implement the trait fn mute, you must also implement the trait fn once. If you were to implement the trait fn, then you have to also implement fn mute, which in turn you must also implement fn once, right? So how Rust determines the trait to implement? So first of all, it checks whether if we move the captured variable. If yes, then it only implements fn once. Only, the keywords here is only, because if you implement fn once, you cannot call the closure multiple times. You can only call it once because the captured variable has already been moved. If we call it for the second time, then we are basically referencing something that doesn't exist anymore. So the compiler doesn't allow that. So if no, so if it doesn't move, then we implement fmute, which also, because of the constraint, we also need to implement fn once. And if it doesn't mutate its captured variable, then we also implement the fn trait. Just wait for Ivan. No, I
asked for in the channel.
Yeah.
You all are Hitler.
Anyways, FN1. Why is FN1 here twice?
Because when we want to implement fmute, there's a constraint that it must also implement fn once. So basically, every closure must implement fn once. So basically, that's it. But if the captured variable, must. So if we move the captured variable, it can only implement fn once. And okay, so we are basically at this branch just now. No.
So if you go back to your code, that means that since the body of the code right now is all three of them the same.
Okay.
It means that if you do the one with the original lineup, it's that you do not need to what do you call that? This is a shortcut for implementing all these things.
Yes, correct.
Okay, so that means that if you want to be fancy, then you can actually do your own implementation.
No, you cannot.
Why would you need three different implementations in this case for the closure? Like internally, I know it's actually have these three.
Call, yeah.
Why?
I'll go into that because I have that slide for that. Okay. For example. Okay, cool. If I don't, just remind me again. Yeah, basically this is the slide. So, before that. So now, if you see here, now you can actually see why this doesn't compile, because you see that here we have like a struct and non-closure, and then we are referencing a variable 1 from the top line here. And when we give back the when we return back the closure and then closure here, we're actually referencing a local variable 1, because that's why it doesn't compile, because by the time this function return, this one is already gone, because we are returning reference. But what if we do move here? When we do move here, what happens is that the struct becomes something like this. And then if we go to here, so that's why it is fine, because the closure here takes the ownership of 1. We see the struct, it takes the ownership of 1 instead of taking reference when we do the move.
So you basically actually do a copy.
Yes. Well, not really. I mean, here it becomes copy because it's primitive type, but if it's not a primitive type, let's say it's a complex type, then it get moved. So yeah. So how Russ determine the trait to implement? Part 2 lah basically. So here we have a string, and then when we move the so basically when we move the string s into here, into this closure, s gets dropped because s is returning s back. You got it? Oh, sorry. It's returning s back into here when we run it. Basically, s gets dropped from, or s gets moved up from the closure. So if we look back at the diagram here, so it moved the captured variable, yes, then it only become fn once, because you cannot do fn mute, because in order to do fn mute you also need to be able to call it multiple times too. So Russ see how the captured variable being used, how it is being used inside the body to determine which trait it needs to implement. So here we have another example. We have like this is a string, and then this is a reference. This is a reference to a string. Stir, yeah, stir. And then since inside the body it doesn't do any, it doesn't mutate or it doesn't move the captured variable, so it basically implements all those three traits, fn, fn mute, fn once. So it reach here. Oh, sorry. Let me see if I'm missing anything. What? I32? Yeah, I should at 64 lah, because 32-bit system.
I don't know. I just curious. Because these days we just assume it's 4 bits. One of those curious.
Okay, so we have another example here, and then I want to show the MIR output. Basically, it's like, let me check, playground.
MIR is when after all your macros, or what do you call it? Is it macro?
So basically, it's the Russ intermediate representation. So this was developed because in order to support incremental compilation in Rust. So they built MIR to basically support the, if I recall correctly lah. So here what happened? So we have some closure here, and then we have some num, and then when we compile, we can actually just compile in the playground too if you want. But
is MIR actually a Rust code that you can just basically copy and run it elsewhere?
I have no idea.
Because it looks like just an expanded Rust.
But the MRI is before going to the LVM, right?
Yes, correct.
It just looks it looks like a editable Rust code if you really want to edit it.
Yeah, but I have no idea.
I don't think you should, but it seems like there's a code generator there.
So as you can see here, the underscore one is actually refers to the closure. This is the closure struct being implemented by Russ, and it has some num variable and of type reference I32, right? Okay.
isn't a reference to I32 bigger than the actual
Yes.
value?
Yes.
I thought you could say
Because
64.
Because you have
Yeah.
you have a pointer, right?
Pointer is 64.
the pointer is always the size of the processor with 64 bit.
I mean, in real life, you shouldn't be doing this lah, because
No, yeah.
it's a primitive type, and then it will implement copy. So it basically just like copy the. So Rust know how to do it efficiently. So now that we know this, this is the same code as before, as the above here. But I just want to ask, what is the type of X? Is it?
You can go. The slide is not sequential. You can go up, down, left, right.
It's the same. It's the same slide. Oh, I mean, you want to see the
No,
output?
I mean, like, just now you just jump. Never mind. I got confused.
Oh, sorry, sorry.
My mental navigation.
Like subsection down.
That one just now is you press left.
I press left.
Yeah,
Here.
yeah, yeah.
I already explained that. You missed that one.
Never mind. Continue.
Okay, okay.
Just like my mental navigation got that. Where am I?
Yes, this is the new. Not really new lah. I mean, like,
Damn kid.
yeah.
I like my slide.
Why are you thinking in 2D? I'm still in 1D.
Slides.com.
I only.
No. It's just
No. It's
my mental.
it's
navigation
text.
got lost. Okay, good.
Okay.
Go on.
They have syntax highlight. So okay. Okay, let's go back here. Now, since we know that closure basically borrows the outer variable, so basically so I just want to know, X here is basically the captured variable. So what is the type of X? Is it?
If you're gonna mute it, so it's actually mute, so the reference then.
No, yes, it is. The answer is either reference I32 or I32 here. So if you look here, it says some num is reference of I32. But what is X here? Because some num is here I32. Okay, let's try to compile this now. Reference I32. Okay, we will see.
Well, some of us is right.
Maybe neither.
What?
There's no such thing.
Then he's giving. Then choice is actually an emoji.
You 32.
So we can say that mismatch type. I expected type unit because I put unit. I put it intentionally so we can throw this error. And then it say found I32. But what's going on here, right? Because some num should be a reference, and then even in the MR output is actually a reference. But why? But why is it I32? So this is Rust doing its magic lah, basically. So if you look back at the MIR output here, so here we have some num, which is basically so lagging on this one, reference to I32, and then if we see here, _2 basically refers to X. How do I know that? Because this line main rs 5. So _1 basically refers to the closure, right? So this closure is basically reference to the closure. So we deref the closure, and then we get back the closure, right? And then we do like .0 to get the first variable, which is some num. And then some num has type of reference I32, and Russ help us. Russ basically deref that automatically. So that's why X here is I32. So it's kind of confusing because you expect it to be because it said like being borrowed right into the closure, but then when we do it as if like yes. So that was confusing for me. Like it took me a while to understand this.
Meanwhile, I think I get it. What are the implications in terms of whether what X is?
I think it just make it just make consistent lah basically. I think so because if you have here some type on the sorry. So let's say if you have the type here as I32, then suddenly if you assign it to X, then it become ref, then it's kind of inconsistent in how you want to think about, how do you want to reason about your code, right? So I think probably that's the decision of us. I don't know. That's just my
But if you like
speculation.
Coming from your explanation, like previous one, then after you understand it, then it looks like it's a very sugary because
Yes, very sugary. Yes, correct.
But because he is copy.
No, it doesn't have to do with copy. If you change it into a struct, it's going to be the same thing. Yeah.
There's a primitive type and there's nothing much things about it.
Yeah.
There's no side effect.
Mm-hmm.
Only when there's side effect.
So now, what if we do the same thing, but we move the captured variable? What we get here, as expected, I32, like the struct that we built, and if you look here, there's no deref being done automatically because the type is already I32. So it matches lah basically.
Only if it's actually FM1. If you reuse the same closure a few times, then it should be something.
You want to see a slide?
must be a
What's the difference?
What's the difference with?
This one and the previous one, move and without move.
Oh, you miss out a lot of things.
I was to reach already and then suddenly I took the wrong
watch the recording.
recording.
So
I face the wall.
so because when you create a closure, basically it creates a struct for you, anonymous struct that is unique. So even if you write the same closure, a closure like x plus 1, you do like x is equal to some closure x plus 1, and then you do like y is equal to some closure x plus 1. In the body it's the same thing, right? But if you try to compare x and y, it's actually a two different closure. Yeah.
Move means that if I'm getting it right, is why you don't need to worry about value is because when you move, you actually you put your function as a reference.
Come again?
When you issue a move, you actually create a pointer to a function.
Pointed to a function?
I don't know how you call it.
But I thought after you move the variable is gone.
The closure take the ownership of the value. Yeah, that's right.
And you run it multiple times and you actually move it between the calls. That's when you really need to make sure that it's actually a reference. Otherwise, actually good point. In closures, what happens if you return the closure?
This is the one I was talking about to you about just now. Calculate, but this is call. Yeah. So this is another another complex example.
It's not reference because it relies on the GC.
Yeah, I think so too.
I think in the GC language, it just implementation is much straightforward.
I think it's a gotcha. Because if you're going to repeat, it's actually because you go between sometimes you run
order move your
Check it.
yeah, check the IR.
You have to mutex it. Or else it's a really weird stuff to do the.
But the mutex is because it's not considering it because of once the compiler is slightly less strict than Rust, you can still write that kind of code and the mutex you have to do it yourself. You put the mutex into your closure.
I think that's all I have, if I'm not mistaken.
To be honest, from someone who don't really use Rust, does this really use it? It's just basically just like Rust does the right thing. The thing that you expect it to do, just magically somehow in the back. It's either when you need it as a reference or non-reference.
So if you need more information, you can go here. Yeah. Okay, I think that's all I have.
Thank you.
Thanks. I just had great aneurysm.
How about NAB?
But I think if understanding this in Rust is actually quite important, because sometimes you have, especially when you want to understand the three types of traits, because some function expect when some function basically takes closure as argument, and then sometimes they constrain it into like fn1s. So if you, I mean, fn1s works lah, because every closure implement fn1s. Let's say for example your closure accept fn, and then you are sending like fn, then probably there's a mismatch there. Usually like fn mute, something like that lah.
But if you want a general one, then you should use the
fn. You should use fn, and then you should see what's the compiler complaining lah, and then you should fix based on the compiler. Yeah.
Yeah, but the thing is just that your understanding higher. But for the very
doesn't
even for the so-called the day-to-day result, unless we have users of compiler stuff, it is only in certain things like measurement that actually comes up. So normally that you don't really
I don't think you actually encounter this when you
So
write it yourself.
so the Rust book basically recommend.
What are you doing?
I continue, just
Who gave you
continue.
permission to do it?
I just see, I just see.
before you
You go ahead.
I can see.
Yeah. Yeah, from the beginning lah. You should see from the beginning.
Go back.
I know it's enough, I know it's feedback. Doesn't make it.
You can continue,
Okay. No, I'm done basically.
Question, yeah, question.
Yeah. So some of the thing I said maybe not accurate totally, because yeah, some of it are probably, yeah, disclaimer. I have to put disclaimer at the end because
How about
I'm still like learning Rust.
how about you?
Wait, before that, I want to understand why it doesn't happen in GC.
Why?
Okay, from my understanding, the GC doesn't remove the second function, the F1 function, right? Meaning it's still there.
Okay. So
That's the reason why GC it works. Right?
In Rust, they care about when does it need to clean up after itself. So it has to be very careful who owns what.
Yes.
Because the owner cleans up.
I think Rust is very aggressive in as long as it's not used, it will be gone.
no, because
Goes out of scope.
yeah, because if it goes out of scope, it's gone. But in GC language, you have a GC that basically
Maintains or
have an
is
eyes,
currently,
like eyes, like watching the
Somebody is referencing it.
yeah.
so
As long as something still reference the object in the heap, it won't remove it. So if you have like a circular reference, then it would be forever stuck.
Yeah, the garbage collector.
it's something like
Some bad
pointers easy lah. Once you don't have any pointer, so you
No,
don't have any
you get
reference.
the analogy right.
Mhm,
You
mhm.
cannot get it. But
Yes.
what's the Rust equivalent?
The equivalent is just that you go there as a family, so sometimes you share a plate, sometimes that everyone still needs to clean up. So when you actually your kid is eating, you
Yeah,
must
so got
take
take
that.
that.
So whoever last is going to
Which
I think it's like this. First, it's
Is
like
that
once you put down your spoon,
P450S.
it be gone.
It's
It be
an old
collected.
model too.
Mine's older.
No, it's like a blind guy that's doing a chicken right now. Once they drop the spoon, once they let the spoon, they're literally gone.
Yeah.
It's not actually clean up, it's just that you lose track of
It'll be
it.
clean up. Actually, it will be clean up.
I'll rather do Python and NumPy.
I think we are doing an
and
analogy of
Netflix and
GC
those
language
things.
versus Rust in real life.
Back.
So when you say like, it's like, can't mention like GC language is like KFC in Malaysia.
Yeah,
you
someone
eat
clean
and
up.
yeah, somebody will clean up for you.
You just do whatever you need to do.
Yeah. But Rust is like,
If your garbage collection is not good enough when during peak periods, that means that you get very dirty and very slow.
Then
That's
you
why
get like
normally,
GC pause.
normally if you have enough resources to clean up after all these things, then
oh no, it's actually not that. People will still clean up for you in both restaurants, in both cases. Just that Rust one is, they don't ask, it's like, Ivan, he doesn't ask whether you like it or not.
Huh?
If you put down your utensils, I'll collect it. If you stop eating, I'm gonna collect it.
Okay.
nice.
But how come I not
You need to connect to the Wi-Fi.
Oh,
Actually, yes.
I connect to Taksuri.
A Chrome.
It's like seems like Rust guys are very thin fat.
Yeah?
Friendly.
I use a Mac and I got four.
So should I say if you use
No, don't buy your first ThinkPad. Once you buy one, suddenly like me, I already have three. I don't know why.
suddenly.
I pity you. I go to
Okay.
Loya, I see all those PT ThinkPad, no
I think the
orders,
old one,
the
they
cheap
last,
ones,
You guys are
X200,
weird.
X220.
Where?
I rescue them, man. So it's a rescue.
Do you name them?
No, not until that. I'm not a girl, man. Girl always name their laptop.
You all name on laptop, but you don't name on laptop.
This one is big enough?
Weird.
But you
The
pick
name
them.
is
But you pick them.
X220. That's it. That's the name.
Oh, actually.
Okay, I'll.
Because you have two X210.
No, I don't buy two. I just buy one.
Huh?
Sorry.
Huh, start.
Yeah, we can start.
Rust to NPM.
Yeah.
Okay, today's topic, Rust to NPM.
Why?
What would you prefer?
It's a topic. It's a topic. It's just a name. It's just a name. You can name anything.
Everything you like.
Then why do you call
This
Han?
you want to get ready for our Wasm?
No, not just about Wasm today. I'll talk about. Okay, Rust to NPM.
I thought you liked Rust.
I like Rust, but then
Why you?
no, Rust not enough. Rust can go to NPM. Take over.
Traitor.
No. I mean NPM. Okay, later I'll explain.
Okay.
Still Rust main focus. That's why Rust is in front. No, that's why Rust is in front. If not NPM from Rust. Okay, why Rust? Okay, here I explain why Rust. From a Node.js developer standpoint, you have okay, here you have zero cost abstraction, the Rust, where most of the things are done at compile time. So like the trace, when you do size of like a struct, you have no cost. When you try in the code, you do size of the mem, there's something to do, mem size of like a struct, there's no value unless it's a box, then you have some cost for trades. And then no garbage collector. So I think he said. Okay, and the last one, safe. You don't get this thing anymore. Every time in npm, sometimes when you run something, suddenly say.
I think this is applicable to all the compile language, right?
Huh? No.
No, I mean, compile or not compile, you still get errors.
Yeah, you get errors, but this error you get at runtime.
Okay.
Up you type everything. Oh, everything we type. Oh, it works. And then when even if you use TypeScript without using the npm, the undefined thing.
TypeScript is a transpiler.
Yeah, it's a transpiler, but then it helps you to check. It doesn't check for undefined.
Okay.
But Russ is safe. There's no now. You only have none. I think there's now, but it's unsafe. In the safe part.
You just mentioned unsafe. You just mentioned that Russ has
okay,
unsafe.
You see.
I think in Rust, if you use things like unwrap, then it's going to panic basically.
Yep.
Because so I think the practice of writing Rust, if you want to be safe, just don't use things like unwrap.
Fair for you.
Yeah, at first we
So
use unwrap.
You need to wrap up.
No,
Don't use unwrap.
so if you
It's the way of a play.
Sorry
yeah,
guys.
yes.
No,
So
but at first when you learn.
you have to explicitly check whether something is a type of sum or none. You have to explicitly check.
But there's also like error propagating, right? Like the libraries, like the error libraries call failure.
Yeah, failure.
Yeah, those. But I heard failure they did something not that good. I heard. Okay, here's a quote.
Read it.
In theory, it would be entirely reasonable to guess that most Rust projects would need to use a significant amount of unsafe code to escape the limitations of the borrow checker. However, in practice, it turns out, shockingly, that the overwhelming majority of programs can be implemented perfectly well using only safe Rust. What is this? Like this? Never mind.
Line break there.
It's not checked by the Rust compiler.
Okay. So yeah, that means that most of the time you don't even in the library you don't see unsafe. There's some helper function like I think it's called cargo gauger.
Make it bigger.
Yeah, I go to that part.
I cannot see my eye.
I can see now. Okay, cargo gauger. So this one will basically checks all the libraries that they use above. It copies I heard it copies some code from the cargo tree, a command to list out the tree stuff. This one is something to check for unsafe in your libraries. Okay, no.
The red one means that it has unsafe.
Yes. No, the nuclear. It's nuclear.
Oh, nuclear.
Yeah, okay, same line. The nuclear and the
What does it mean by nuclear?
So it means that there's like two.
You know the funny part is that other languages performing operations.
This unsafe.
Yeah.
How many unsafe is there? You see like 2 over 2 unsafe, 99, 92 unsafe expressions.
Okay, so it's bad.
It's bad for libraries, but then like some interesting library like cert, the serialization and deserialization framework, a very popular one in Rust. There's like last time I have a lot of unsafe. I heard that reduced until like minimal, but then still using the safe counterpart, there's like no performance impact. They just write it in like a bit different way. Okay, what's the question?
What does it mean?
Huh?
So break is about unsafe operation contained inside the library.
Okay.
Okay?
Yes.
Okay. That's all I want to know. It's like a different way of linting your library codes in case of.
This is just a.
But
But
this is built-in, right?
this is not linting. This is helping the other libraries, helping you to check how. This is just showing.
This is built-in into cargo or?
No, this is a cargo extension. Maybe cargo have like cargo search is very bad, right? Cargo search, you cannot search anything. They have something called cargo S search. another component.
The better one is to be LSS first.
No.
Come on.
Sorry.
No,
No.
Okay.
No.
Okay.
yet another search.
Yeah, this one.
YASR.
Yeah.
Okay, then. Okay, okay, continue. You don't get the safe part is when it compiles, it works unless it's your logic error. Okay, at least you don't get not uneven. Huh? No, like C, if you get like null pointer error, double flow, like those memory error, but Rust also safe. You don't get double free. You don't get not allocated.
No, because in Rust,
The C guys will appreciate this.
even if you panic,
Oh, we appreciate
Huh?
so even in Rust, if your program panic, it is still considered safe. So unsafe in Rust is considered as something where basically you doesn't follow the memory safety. So that's called unsafe.
Okay.
So even if you panic, it's still safe because it doesn't really do anything with it.
Basically escaping the checker.
Yes.
Yeah, mostly used in like libraries with C, like bindings to C. They'll use unsafe or also used to interact with the hardware. It's also unsafe. Okay, just the main point. Continue. The first way, the WASM.
I already said.
No, not just WASM. I say not just WASM. This is the most popular way. Like you search online, Rust npm, definitely this will show up. I've seen other ways also, but then later, this is number one. You see, that's why.
I don't get it. What was Rust npm again?
No, I mean npm is the packager, the package manager for the node, right?
You're wrong. One is the architecture. What hunt is actually you this keyword Rust and npm. Then you get results that npm packages that is written in Rust.
No,
No.
you get how to write Rust. Okay, just search.
Okay.
Okay, this not.
You can install Rust on npm.
No, this not the. I don't think this is the Rust that we are thinking about. Okay.
Written in npm.
So the first way, the WASM way. Then yeah, npm can be written in Rust.
Oh, of course.
You answer.
Okay, so WebAssembly, a big introduction, is a binary format and it's compact. Used for the web, it just the one of the aim is like it's faster, and library authors can use it because you can do the optimization before running, so the browser have I think Mozilla have a good write-up about this on the why WebAssembly, and then how the parsing works, and then the optimization, how it can be shorter.
How is it different from Java
Opcode?
Java, what? Java, yeah.
JavaScript.
Java, not Java.
But wasn't WebAssembly a standard, right?
Technically Java. Oh, technically, I mean, like, to me, it's just like WebAssembly is just basically the end. It's like you need to do stuff with it.
Yeah, but it's not just to WebAssembly is not just towards WASM. No, not just Rust. You can do in Go also.
We know that. Okay, come again. Okay, what's the difference between assembly and machine code? Because you need an intermediate step to run WASM. So I don't know that WASM in terms of the opcodes. I mean, it's like VM.
But you need, right?
Yeah.
Because it's not compiled to the machine code.
From a Java opcode?
Not sure.
You just search and not use those. WASM is register based or type based? Type based, right? Remember, type based.
Yes, because it's on the runtime.
Yeah. So it's Java.
What's the difference?
But somebody implement the
I never heard of opcode. I never heard of opcode.
What? It's on.
Kids nowadays know
Yeah, you know what is awkward in your study PS15.
Opcode is.
So your question is why
Opcode 90
implement?
and opcode different. Opcode 90 means no op.
So your question was why use WASM instead of like using Java?
No,
Java?
specifically, yeah.
That opcode.
I mean, I know WASM is popular and how it works and all, but when you actually step back, it's just like if you need to have something else you actually do before you run it.
Assembly is not JIT. Web assembly is not JIT. It's not JIT.
So it's actually this, you can just, so what's the difference of XAssembly?
No, because WebAssembly is not architecture specific.
But it's not assembly.
It's not assembly.
That's why it's compiled to a format that is used for all the browsers.
For the browser.
Yeah.
So the origin.
Come again, using Java opcode and IR or
Somebody implemented that.
Yeah,
And
but
name
probably
it
they don't want.
But Java opcode is specifically for Java, right?
I'm
Not
okay,
true. Not true.
Not just that.
Huh?
JVM.
Java output used to be pretty much on the browser as well.
Titan? There's no Titan.
Oh.
Yeah.
Closure. So, but WebAssembly originally I'm just creating simplified on Java.
I think also Java are exiting the market just like Rhino and stuff. They are becoming
It's just, I mean, it's a
Suddenly
different
you realize
language, different branding.
Where
But
is
in the end,
it
it's deja vu.
just repeating something or redundant?
Because most of the WebAssembly claim to speak is just that LLVM can export to WebAssembly.
one of that.
So in other words, that if LLVM can compile it, WebAssembly can run it. That was the claim to fame in my opinion. So that's why it's easier to port over anything that is LLVM compatible, like I'm doing stuff.
Wow.
It's just that.
But WebAssembly is a standard on the web, right?
Not
Not
true.
opcode.
Yeah.
But it's
How, okay, very simple question. Okay, how many implementations of this type are there?
so the mainstream browser already support it.
What are the three main browsers?
Firefox, Chrome.
Another one
it's
is
a trick question.
I thought Edge is dead.
Okay, what else?
I don't know. The third one.
Dinosaur.
You do know this is recorded.
You know, IE is already used it.
That's why I asked him.
IE.
So if it's a standard, it's technically only implemented by these two guys.
Yeah. Because even Opera is not using.
Opera is using Blink. Opera is basically Chrome.
Yeah.
Chromium.
Essentially Chromium. That's a point.
But I heard Edge also switching to
Unless you consider Safari.
Edge also switching to Blink, right?
Yeah.
That's the point.
No, Chromium.
That's the point what he's saying.
Chromium,
just
not
now.
Blink. Chromium.
Which is
Safari,
still
you consider Safari.
Blink.
No, Blink is the
Engine.
JavaScript engine.
I thought.
But they're using Chromium as a base. Edge is using Chromium.
Okay.
No. Opera is using Blink. The Vivaldi using Chromium.
Okay, never mind. Continue. Continue. Okay, why Rust is very suitable for WebAssembly? Because
Come on, I mean, what languages cannot compile to WebAssembly?
no, because it has no garbage collector.
actually there's no Python implementation.
If there is garbage collector, then there's like tiny cost. Okay, that's not important. What Rust have for this WebAssembly, there's a wasn't bind gen, JSSys and WebSys, something new. But I remember one of JSSys and WebSys. I remember one of them, right, is generated. I don't remember which one. One is handwritten and one is generated.
What does it mean?
This is like the something
No,
for
I mean, generated. What does generated mean?
they generated from the standard. I remember something like generated from something, but I think it's the standard some files or what. These are the files.
So basically, WASM Benchen, what it does is that, so in order for your Rust code to communicate with the JS ecosystem, the WASM only supports sending numbers basically.
Integers.
Yeah. Integers. So you cannot send string, cannot send a complex object because everything must be sent as integers basically. So what wasm bindgen does is that it helps. Let's say for example you have a struct in Rust, then basically what you can do is just you apply some attribute or whatever.
No, you don't apply to the struct. You apply. I remember.
No, you can apply to the struct, and
struct
you
also.
can also apply to
These are
function.
bridges to the
Yeah, so basically it helps to generate all those boilerplate code to communicate with the JS. So that's what wasm bindgen does.
And JSys and WebSys are the one that exports the JavaScript stuff to the Rust. Okay, here I just like hand typed this, so I need to put a warning. So this is basically how it looks like for wasm bindgen. Okay, except I missed something. Okay, let me edit a bit. Eh? Oh. Okay. So basically, it's something like this. You just need to put a wasm bindgen on the top. This one on the top. If you take the JavaScript functions and put it into the local namespace. Yeah.
Oh, this is like a bridge with a JavaScript function. Yes.
It's like generator. So basically, you let your Rust expose the alert to your Rust code, and then for the Rust, okay, this is string. Never mind. Okay, so for the Rust, you have a function message this string $str, not world, and then you can use the alert directly here, and then you can format. You cannot just use like JavaScript. You need to format it with Rust. This is one of the downside right now. You need to format it with Rust first as a whole string, and then wasm bindgen will do all the magic behind and make it wasm compatible. So this like hello world in wasm bindgen using wasm bindgen. Okay, the tradition, the manual way, how they do it. Huh? No. How you do it, basically the ways is like you need to add the Rust up target, you add the wasm32 unknown the target, and then you need to build as the target. Oh, okay, sorry, first. So because you cannot see.
Okay, I got it. The answer to me in terms of WebAssembly and Java code is that the wasm is designed to be able to interact easily with the JavaScript. So that means that embedding the features is actually much more easier.
Oh.
Where Java is actually in its own sandbox with minimal amount. So all these things that he was mentioning means that those ways of Rust will be able to interact with JavaScript.
So basically, it runs natively in the browser.
It's not even run.
It's not even run natively. It runs under a stack virtual machine browser. So it's actually not native code per se. So it's actually just still technically integrated. Except integrated in
No, it's not. Yeah.
Still integrated because
it's a stack machine.
But it's already compiled.
Because the idea of
pre-compiled beforehand.
Let's not go there whether compile is actually compilation.
Okay.
Because
So
it's not native code that you're running. Because wasm, the output for wasm is not any ARM or x86.
Yes.
So meaning inside the browser stack, then have a stack and heap.
Yeah.
But that's why the architecture is unknown. That's why the architecture and the triplet here is unknown. That's why you can run anywhere. Okay, so basically what you do with the build binary is somewhere around here, and then you need to write the JavaScript manually, and then you need to write the initiate streaming, the WebAssembly thing, initialize the module, and then you can only use the WebAssembly. Okay, what else?
Huh?
How
big is the hello world?
Like
the artifact, the build. You can finally.
I remember wasn't by default is very big. There's like some optimizer to make it smaller. So right.
Normal size like.
Not sure.
Let me check the Go version of Wasm.
I think it's quite big, but you need to manually tweak something to optimize it for now. And then okay, what makes it easy? Then they introduce Wasm pack. It's like a helper around the Wasm way. So it's helper to, that's what they say, pack and publish Wasm. So they have support for browser and Node.js, but not both. Yeah, I found this very weird. Like this year, that this their target is an open issue. They are reading.
It's very weird because
they're planning to fix it.
Because most Node.js can be transpiled to browser.
Yeah.
So it means that if you need to, then the transpiling and stuff will be a bit weird.
No, but they can build to both.
Yeah. You need to build both.
But they cannot. They can build one of them right now. Yeah. So if you want to have a browser library and you want to have a Node.js library, you need to build it separately. But the code is the same, but the build, just the command to build is a bit different. They want to fix this so that the library that you generate can support both browser and Node.js. So, and then with this, you have less enum power, like error handling fallback. I don't think you can use like result. You return a result string and then with with a structure for error. So you can't do that. You have like less use of the Rust way to do error handling, like the fallbacks, propagating errors in the Wasm for JavaScript parts. And one of the nice things is they have a very simple API through using proc macro. Like just now you see this Wasm bindgen, right? This is a proc macro in Wasm 1.5, I think. Proc macro is introduced. 1.15. But for proc macro, right, it's not implemented for 2018, right? No, without the extern crate. You need to do the macro use thing. I think proc macro is stable, but then you still need to use the macro use and then extern crate something.
So the idea here is that you can write the Rust code.
Wait, I think
once it's actually compiled to Wasm, you can actually use that as npm, so that in your other JavaScript projects will be able to use your Rust code as another module for you to use in your JavaScript based application. Does it, or how is it? So that your Rust code is normally a library that you'll be using from JavaScript.
Yes, usually to replace the performance sensitive parts. But you can use it interchangeably. Like you want some parts to be written in Rust, some parts to be written in Wasm. They want to make it very, very easy for you to do that. So that's why there's this Wasm pack. You just write some Rust code and then you just publish to npm.
Okay. So how would let's say that the more complex JavaScript types, serialization or something, how would you be able to run and consume things more complex on the higher level JavaScript stuff like I don't know who the Wasm thing is on. How is the string types handled to and from the JavaScript stuff?
You can use cert. I think you can use cert. You need to use cert for those.
Cert lah. Which means is that
I haven't explored the passing like JSON pass.
Still, you need to have another translation layer between the primitive types of same thing with other languages that move on. You need to go to translation layer.
Not sure about this. Maybe need to check. Huh?
That's why you can pass string between.
Yeah, but he don't mean string. He mean passing JSON.
So let's say that your existing JavaScript application handles some complicated JavaScript stuff on JSON and all stuff. Oh, so slow! I want to run it faster. normally if you want to call your Rust program, you'll be passing the entire JavaScript object to your Rust.
Yeah, it's best to pass everything.
String and then you just go to isolate Rust, run it.
Yeah, but there's also some cost calling them here and there. But if, okay, so this is a basic method to use button pack. You just button pack, build target Node.js, release, and just publish, just like that. Okay, so until here, let's continue with some what is that called? Hands on. Okay. No. Okay, I show example how to. I did already one, but then I did already a little bit. Okay. Okay, this from PubRS. I'll do a demo with PubRS.
What is the PubRS?
Okay.
What is the PubRS?
Is Pub the templates we implemented in Rust for performance reasons. But I don't know why they choose test is slow. No, I heard it's slow, but then they say they are fast. But yeah, that's what they say. There's another library called norm to help to do the. You know what are these calls? Called what are these? Norm test. I think they are parser libraries or parser tokenizer. Parser combinators test. Yeah, parser, something like that. So basically we implemented part in Rust and it became this fast. Is it 10 times faster? Yeah, seems so.
This is on Node.js or the browser?
This is for Rust only, not Node.js, not browser. That's why I need to show demo for this. Okay, so this is basically.
Exactly this is what how does the part template look like?
Huh?
How does the template look like?
It will be something like body block herb derp herb Google derp YOLO jaja.
So you expand it to it.
Okay, wait, something. Okay.
Who uses part?
Sometimes I use.
No, who else outside?
Huh?
Who else?
Who else? No, some companies that I work for also use part.
Alright.
Mostly Node.js.
Browser. HTML, yeah. Node.js compiles it to this No, this is not example. Something like this. Yeah, here. First page. Yeah, this example, this P. No. It lets your HTML looks better.
No, it's a templating engine.
Something like this.
It's not better, it's templating engine.
Yeah, so you can do with like this, and then it makes it like this.
It gives HTML forgiving.
Yeah. You don't need to put like end tag and opening tag. You just need to put. No, but this looks easier. This is based on indentation. This is similar to stylus. You all know what is stylus?
You know that's the same something I heard about.
It's a templating language that nobody has heard of. I do not do this. What's it?
CSS.
It looks like it's a It's like a cold to deep.
Okay, so it's something like this, but then Park is for HTML. This is for CSS.
But yeah, what's wrong with it?
Okay, never mind. This is not JavaScript Meetup. Okay, go back to
What's
topic.
wrong with this? So you cannot just use it like it is.
Okay, back to topic.
Yeah.
Okay, first what I need to do is
Yes.
You know that
Deja vu is no.
that's what no what you saw in that movie.
Is deja vu what Emmet was trying to do?
Emmet, at least it's useful.
You want to that is bird.
Right. I want to.
At least it's readable.
Yeah.
okay, but now they put everything here.
Yeah, it's like Emmet.
No. Emmet is
Okay, I just change it to
just for the editor.
I just changed the edition 18 to be easier
I only
to
have problems
stuff.
switching between JavaScript and other languages and Python and Go and stuff and the different templating and then Helm template on the two people already.
Yeah.
I stopped. I think Helm is a very good idea, except that writing all this Kubernetes stuff in the Go template code.
Like you said lah, all template code plus all templating. There's never a perfect one.
It's the mental load is much higher if you want to keep switching between the different templating languages. So sometimes even though you put more Go,
like we were it's a language for conflict.
anyway, it's just personal.
What's that?
Continue.
Okay, so I changed it to 2018. The file was originally just in main. This file, originally just this, and then I split it into a library as well. So the library and the main file. So this is the library. This is the binary file that it runs, and to make it into other, I need it in binary. So I put this binary. Okay, now let's start. So first thing, I need to add wasm. What do I do? I need to add in cargo. The first thing that I need to add is wasm tag. Need to build for Node.js because I want to use it in the Node as a Node.js library, right? So I need to use the build to Node.js. Oh wait. Okay, so first thing you need to add the crate type. You need to add a crate type for this one. And this is for to specify the build type. Let's say cdylib is to build for dynamic library, and rlib is built for the other ones like lib and main. So it still works.
No, fun fact, I actually live very close to Sayana. 17 minutes.
I know. It's less than an hour.
I send you that. Taman Selayan Raja, right? Right over the
How long does it take for you to compile?
To wasm. This one.
Tomorrow morning?
Half a minute.
You can save about 1 minute after you run your code so that it will compile.
I think you should use something like a capture, so you don't need to compile it every time, or you just show us the product. You don't need to show us the compilation.
Oh, so I just show product.
Yeah.
Okay. Then we faster.
Sorry, watch more few shows.
Sorry, I have to leave.
Okay. Bye bye.
Thank you for the thing. It's very helpful.
Oh yeah,
Thanks,
I'm
man.
gonna ask you whether you got time for them coming.
Yeah. You want to interview or do more meetups?
No. We will interview
Get the
on
channel and.
So I think one of the FAQ is also going to be that if you use Rust in terms of the context of companies using Rust or anything related, what do you use Rust for normally? Why would you so much into Rust?
I just want to learn low level stuff.
Okay.
So you learn like C.
For I just use like Haskell.
Oh.
You use what?
Haskell. It's a fabric. It's a fabric.
Oh my goodness.
So yeah, we have got a lot of stuff to interview.
Okay, bye.
See you too.
Hanso is flying back already.
Huh?
Flying back.
Tomorrow morning.
Oh.
You know one of the JavaScript up, he actually compiled the whole tool chain. Yeah, we have to wait for him to like 20 minutes to compile the whole tool chain.
Okay, I just show the output. Okay, here's the output.
We have to wait for him to do the tool chain. You don't have to. You know you can actually screen. No, there's actually a software to record your terminal. Use a
Script
or something. Let's go up.
I know.
Then you
But I
don't have
didn't.
to show us this. Actually, we are okay. You're not bluffing us. Definitely. Because you have the result.
Okay, this is the result.
Okay. After, okay. All we get is undefined. You say it's very safe?
Okay, like this. Let's say I pass random hello world.
Yep.
So it will become this.
Okay.
S equals to. Okay, let me use the just now the example. This one for the
I was looking at the Go example, how they actually use the Go itself. Basically, wasn't in different languages so that they have different ways to bridge the language.
Oh wait. Not this one.
But because they are all based on the same backcode like kind of a standard, so it became in a way easier.
Okay, so after I change it, you see, I can just use, this is WASM. I can just straight use from the node.
Or JVM4.
The output will be something like.
I suppose for this it makes sense because
So this is the.
This templating, passing and all
But the
that.
performance boost is based on how much the browser allows it, right? Because
it runs in sandbox. So it's the JavaScript stack in sandbox.
But
fast, but not.
But if
Oh,
you
it
use
generates TS for you
Node.js,
also.
it's on the server side. So
did you generate the package?
No, this generated by WASM pack.
Okay.
So you just run WASM pack build target Node.js, then you build this package, and then in the node part you just require the package.
oh, so with
Just like this.
choose lah if you want to
Yeah.
put it server side or user side.
Yeah, server browser also can. Some like there's a game called. Okay, show this game. Those response. This game works in the browser. This is also on Rust. In Rust.
Actually, one use case that Bruno mentioned which way, right? You know, because JavaScript doesn't run JavaScript, so Watson actually stopped it.
Yeah, already built to WASM.
How big
But
is
it
it?
actually
How big
depends
the file
whether
is?
they can implement the tool.
Yep. It depends on the protocol whether
LS minus A.
Oh, it's doing the gRPC, but it cannot actually do the bidirectional stuff.
But browser 128K. Okay, yeah.
No, this is not release build.
Or not released.
Yeah, this is just debug build.
The fuck
Yeah, this is
BGJS?
actually smaller than the Go version.
This is
Smaller than?
debug build.
About 10 times smaller.
So it could be smaller, but use this.
I think Wasm they use it internally. I remember. Maybe they mentioned something like the minimizer in the Wasm there, but I don't remember whether Wasm Pack does it for you.
Okay, I mean, you can
So after you do that, you can just
you generate lah.
in the JavaScript part you can just require like this, and then you can just straight use the function.
Yeah.
This is Wasm Pack.
You don't even know it's WhatsApp.
Okay, so the Wasm Pack.
It's like IoT. It's fun and fun, but
So but this is a general library, right?
for real life applications.
No, that people do have real life, but it's not within our circle. So for example, I met a guy, okay, this is internal. There's a sentence that was phone doesn't provide, so I have to combine it with the microservices. Yeah. So no, it's a very general thing.
I'm talking about in terms of usage of Wasm actual
No,
traditional.
that is a very.
I think for the part use case,
Because like
actually,
Wasm to me looks sexy, yes.
but
What IoT sometimes is sexy.
You want to do machine learning in browser?
No,
WhatsApp lah.
No lah, wasn't access to the GPU, but if you don't have access to GPU, it's exactly running it as a CPU.
No have, right?
A good benchmark is actually cryptography.
But you can use the OpenGL crate, the Rust crate,
But I don't know how
OpenGL
much
works on
you get.
works on Wasm as well.
Because the browser JS
Does it run faster?
Those ads mining.
The WebGL,
Coins.
WebGL.
it's not directly translating to the machine code.
Are you thinking what I'm thinking?
Okay, so the reason why I'm thinking the cryptography is a good test is because those things are math functions. So, and sometimes they optimize it by going down to the level, lower level code.
You're fine.
We don't have.
Stupid!
But the use case of Wasm
That's
is a bit weird. Why?
Okay, continue first,
You're
continue.
doing a lot of words just because you don't like to type HTML.
Yeah.
No. This one thing is performance you can use it for. No, but you can use it for performance. You can use it for performance.
Yeah, I know.
So
we're just playing with that stuff.
okay, for this library, it is a general library. So we don't want to include Wasm bindgen here. So instead, we have there's a build time dependency for just Wasm build.
Okay.
If it is not Wasm build, it won't include this. So this is like a dynamically libraries chosen. Like Node.js, you include all the libraries in package.json, all is needed. But here, you can specifically say, I want Wasm bindgen for just this
The thing that
architecture.
for me, Wasm is the switch between there's a lot of effort being done for porting over to browser, but that also improves the way you do UI and stuff, like also graphics on browser.
One use case,
buttons.
you can use it to store a lot of data in a more compact format.
Yeah, I agree from that.
Also rendering like math will be more performant.
So let's say you load data from someone else, or let's say something from manual library or something. So rather than storing all the data in JSON, use it to store it.
Now let's abuse it. It's like going back to the age of Flash already.
Templating is not very strong. The browser is pretty good.
Yep.
The browser JS is pretty good at it.
No, but that's not the main thing. I just get a random library and then just port it to browser just like that.
No, that is just picking on you. For the sake of picking.
Okay, so here.
I thought you're immune to this kind of picking.
No, but it's not related here. So basically, what you do is there's a architecture specific code to generate. Like let's say for this architecture, you use this library, and for just Wasm, you include the Wasm bindgen. And same for the functions you expose as well. For wasm, for non-wasm, you use this code, but then for wasm, you can use wasm bindgen for this. Why do I need to separate? Because like wasm bindgen doesn't have like result. Like Russ have like result and then return some special errors, but in wasm is not supported. So instead, right now what do I do here is I notice that I need to return an option of string to tell because you cannot propagate Rust error into JavaScript errors. So you need to either return some or none here in this case. So this part is a bit different, and this part is generated to exported as wasm.
But what does this actually do? What it actually do on high level?
So this is to separate the general library and the wasm library functions.
No. Don't think about, I'm asking about what's the functionality of this function.
This function.
What does the user use this for?
Or this function is just now the one that you see in the Node.js. That this function, it passed that section.
Okay. So it's actually passing the input into template string into a HTML.
Yes, and if there's an error, like
so you actually is the configuration already defined in the file, or it's something that you have to do yourself?
Which one?
The config target art wasn't bindgen. Is this something that you add manually, or the library will be added?
Which configuration?
You have to edit yourself.
This one, you mean this CFG?
Yeah.
You need to edit this one. If
you have to add yourself.
You don't need to add this actually, but then the thing is we want the same function name for both.
So it's not directly a part within it.
This is with
performance.
But this is to export this function to the wasm.
Yeah, I understand that you're exporting this. What I'm saying is you're effectively having a fork of your own library because you're using the source code, right?
Some, most of them.
Yeah, so
but because this part, they don't have the result.
Yeah, and I understand that you don't have the result, but it seems a lot of work. Like, even though it's two lines, but it's two lines of configuration every time there's new version. But the point is, you just make this library workable on Node.js. That's the point, right?
Yeah, but then, okay, so this is until here. And then the issues I found is, why do we even need to use wasm in the first place?
Yeah.
Then there's also Node.js bindings. Like,
and not just binding, it's like how people do machine learning on Python. It became just
it happens that people wrote the
It's a glue.
it's a glue.
wasm.
For a language they're comfortable to work at.
Yeah.
So JavaScript become a glue.
Yes. So in this case, yeah, okay.
I noticed that because just now all we do is just Node.js.
Yeah.
Then why do we even need to use like wasm at all?
Yeah.
Then we can just use the bindings.
Yeah.
Instead, there's something called neon.
Yes.
Okay, this is another example. This is neon. It's more powerful, but then a lot more complicated. You don't get like similar Rust code. You need to write like a function context.
Okay, what does neon do?
What does neon? It's like Rust, a Node.js bindings for Rust.
Okay.
This one is just for Node.js, and it exports the. What's the main? This is using binding. The other one wasn't.
That was binding also.
But that one is compiled to WebAssembly. This one is compiled to the dynamic library. No, this is compiled to dynamic library. This is different. This is compiled to the dynamic library.
Oh.
That one is compiled to WASM.
No. Tell me if I'm wrong. The first one is you are exposing your function to Node.js. Your Rust function you compile it for Node.js. This one looks like you're using Node.js from Rust.
Yes.
Okay. This is the one that
something like this.
The other one is that you can also import JavaScript stuff from the also function.
Yeah. But this one is not for browser. This one just Node.js. Node.js.
Use it for Rust.
This is like the bindings.
So in this case, normally the user
I'm really confused.
really like a JavaScript library, and you want to use it in Rust, you can use this to use.
Right.
It's so meta.
Huh?
I don't understand.
No, I repeat for you. Rust people, they like the Node.js library so much, they want to use it in Rust, so they use this. Correct?
No.
No. So
This is just like
what explain?
there's also like Rust to Python bindings, just bindings for external libraries.
Yeah, but that like to see Rust to Python, just the WASM binding looks like Rust to WASM, which is available to Node.js, right? But
This is FFI on JavaScript or FFI on Rust.
yeah, but it looks like
FFI on Rust.
you are using Node.js inside Rust, right? Without importing, right?
Not to sound, you need to import a lot.
Yes.
This one you don't have to import.
This one is a hello world.
Okay, so the point is so that you write a JavaScript on Node.js, import the Rust function, or the other way around.
So this one is you write the Rust library, and then you write another bindings using this neon.
Okay, so the whole point of this exercise is so that your JavaScript can use your
I need to cut this out.
Yes.
Okay.
Let's see what we can do first before we let's continue first.
Yeah, this is what you can do.
But this one compiles to Rust, right?
Huh?
Does it compile to Rust?
This one compiled to dynamic library.
Huh? Oh, that's my ouch.
That's mine.
This one's compiled, huh? The SO file in the Linux where you can import.
Yeah, by whom? This one is for yeah. Okay.
Yeah, this one.
But
Yeah, dynamic library, right?
Okay, so you import the JS then export it as .so.
This the output is not .so but something else.
Okay.
But this is a dynamic library.
Let's continue first.
Okay, so what is the main thing? It exposes some garbage collector stuff like you see here. It's a bit different. You can use JS string, you can use JS object here. So it's not really the normal Rust code. Everything you need to switch to like JS something, JS something.
It looks like a JS FFI to switch with JavaScript itself, not WASM. I mean, just continue first.
Yeah, but this for Node.js. And then basically expose some the garbage collector stuff. This one is like more complicated to get started. This is just like getting the one value from the function context. This is just getting like one value. And some more you need to use another weird thing to assert whether this argument is string or integer or stuff. So it's more complicated, but then you need to tweak your library for this. But I believe this is faster, maybe. It's not compared to WASM. And like you still need to write some minimal JS code. No, it's not compiled to JS. Later I show the output. So basically how you build stuff is Neon build and Neon, but you can't publish. They don't have.
Can we see the result of Neon build?
Okay.
I'm still trying to understand what Neon. Oh, I don't know.
It's kind of like these days that
You see the ad from
It looks like FFI for me. Compose JS
in Golang Malaysia.
from the description of the idea.
nothing to do with
But this one is a lot better because when you see, but this one you get the Rust error here. No, this one is not a Rust error. This one is the error in. This one failed to downcast to string is the Neon error, and this one is the Rust error. The error that.
Index.node. Can you see what is index.node? I think it's a node. It's a JavaScript because it's a FFI.
what the hell is that? What?
You have this, something like this. Oh, out battery. Battery. GG battery. Oh. Okay.
What?
I plug in the.
What? Is power?
Yeah.
Just now, because the way it looks like it's trying to bridge Java. I think you're trying to compile it to JavaScript. Because that's why you need the FFI, the JavaScript FFI, because it looks very familiar with other, even like Gopher.js or other stuff that compiles to JS. When you compile to JS, then you need the FFI.
Yeah, but other bindings also there's also other bindings for that.
Just curious, what were you why did you go investigate Watson?
Because I want to try out like using Rust in the browser. I saw people writing code like just one Rust code that can be run on the browser and the other machines also.
Yeah, like
So you can run a web server inside the browser also, right? With Watson.
Web server? You don't need a web server.
NSA already did the second smaller processor.
Then you can write you can run an operating system.
Later you want to download.
I had a huge argument with what's the name?
Later you download Chrome. Already 4 gig. 4 gig.
What?
Chrome. Yeah. Maybe 2-3 years. Chrome will be 4 gig. Size of
What's the email?
Good, right? Yeah, but more.
Okay.
One of these days, you can run Emacs in Chrome.
Yeah, you can run Chrome in Emacs also.
Checkmate.
You know before system D come in, you can actually Emacs can run as a project zero. Some people use Emacs as project.
But one of the advantages of using Neon is that you still can preserve the Rust type, and you can easily make use of your existing errors. That's one of the main use. No.
Can we see
Errors from Rust.
Let's continue from just now. Can we see like what's the compile result in the native directory? I think it is JS index.node. Yep. Oh, two. Okay. Then it's weird. Or it's compiled to Node, the Node.js file code. How big is it? No, it's not. How do you use index.node? You just import here. Just use.
No, this is not release build.
So you can just here type node.
what happens if you run index node?
Import. Yep. Required here. Here stop on it. Just stop. No, just it. Remove the entity. Require dot.
Oh, just now I did this already, right?
Okay. So it means that.
Because this is.
The difference is that is Node.js bytecode. Or something like that.
No, I think it's this basically the tongue. If you know if you use require this one, just by this one thingy, the native thingy would actually get and actually run the elf.
CJS.
What the hell is it in elf? I don't get it.
Node.js module. Shared object for Node.js runtime. Basic modules. But not Wasm, it's another standard.
It doesn't get it because
of course it's faster.
LDD is actually the elf executable. Sorry, LDD. Chat object, okay, chat object, yeah.
So of course it will be faster because Wasm is still limited by the runtime, but this is not fixed by OS. This is an extension for Node.js.
Got it. Node.js, when you run natively on your server and all stuff, doesn't really run.
It's a native module.
Yeah.
Not on the browser.
But the title of the software is
No, this one you can put it in npm, right?
Yeah, you can put it in npm, but it only runs on Node.
Yeah, it only runs on Node. It doesn't run on the browser.
I think
but npm is not used for browser.
I think he put it also like we talk. One is Wasm, one is native modules.
Yes.
What you're supposed to talk about is native modules.
No, I want to talk about both. At npm you can put Wasm, right?
Just now the way you explain it, because we try to understand what you're talking about, because we thought you.
That's why I show one, the Wasm. Two, the bindings.
I don't never talk about Node native module. So why we never talk that? I don't understand.
Native module. Of course, this will be faster because it runs on the OS.
Okay. Then.
And it cannot be used on browser, right?
It also cannot be used on other computers other than that. Yes.
So basically, this project is a JavaScript library on the outer side.
Yeah.
And then inside there is Russ library. You see, okay.
No, because you compile it because it becomes a SO. You're binding the OS libc now. It's not inside outside anymore. It becomes OS libc that the Node.js runtime understand that can use. It's not, but Wasm is different. Wasm, because runtime is still limited by the sandbox.
But then the question I'm asking is that how the heck do you be able to take this in a way that other people understand it?
Even he doesn't.
I don't know how to explain. Very hard to explain.
Application. Why? I can't get any simpler than you.
Sorry, I can't get any simpler than you. It could be context, because you actually use the Linux server and you understand Linux.
No more. Summary. One summary. But I don't have question mark. Question mark. So basically, here is a Rust project in the inside. So you still get to use the Rust stuff here.
The funny part is that,
but in a
it's still library, Rust library.
I understand that because luckily I read up a bit on Node.js, the runtime and stuff.
Makes it easier to actually understand.
I think the word you should use is native modules for the Node.js runtime.
Coming from C or
what you did?
No, just native module. Just now the other one is Wasm.
The latter one is not Wasm, but it's for the Node.js runtime.
The previous one is the.
Wasm. Previous one was Wasm.
If I just did Python before, I would.
But this one is also npm, right?
No, luckily I read about Node.js before, like the native modules.
You can also
This is that, okay? If someone's from I don't know, just a Ruby background, or PHP background, or Python background, how the heck do you actually get them to actually understand this?
Oh, you should do a PHP one also.
That's why you.
Because PHP modules are written in
So lah. Not just computer science.
Oh, Zen.
No, not Zen.
Think code school. People from code school.
Yeah.
Bootcamp before the.
Yeah.
You're doing two different things. Wasm is on top of browser.
So
no, Wasm can also run on Node.js.
Very simple question first. Do you know C?
A little bit.
So put it this way. put it this way. Wasm runs after V8. V8 is what? V8 is the just runtime that Node.js is doing. So it runs inside there. But the later one, the SO one, is actually runs on the OS.
Yeah, but NPM I mean as in publishing to NPM.
Yeah, publish to NPM, sure, but the limitation of the second module only works on the OS, right?
Yes.
You cannot work and on. You cannot transfer it to browser, right?
Yes.
Yeah. Understand this now. That's why it's different.
No, but if this the topic.
That's why application. Yeah. No, because I got really confused just now. Because they look like FFI.
No, as a bloody engineering or manageable role or stuff like. So what is understand this?
No, nothing.
Even customer doesn't care.
That's the problem, right? Sometimes like
Because
you view it on a different angle and the perspective is like sometimes a lot of these things that crap doesn't really matter.
no, that's why bootcamp school.
Nothing matters anymore.
Because the type of subject that you do,
Essential is main.
You get
That's
depressed.
why when you get a Ruby developer, you ask him to make Hello World. First they do is them install Rails.
Huh?
That's the only thing you do.
The FAQ for any developer from there comes to you don't care Rust or Google. Hey, what framework I use?
Huh?
Nah, let's stop.